Hello everyone, I am Dr. Bharat Kesari Swami, lecturer in mathematics, Agarpada College, Odisha, India. So, in this lecture, we will discuss the differentiability of the function. We will discuss the differentiability of the function. So, these are some outline what we are going to discuss. First is introduction, then we will come to definitions, then one-sided derivatives, then relations with continuity, then some examples. Next will be rules of differentiation, then derivative formulae, and then applications, summary, and practice. So, what is differentiability? So, what is differentiability? So, it is a measure that how smoothly a function changes. So, how your function changes. That means it may increase, it may decrease. Okay, so it will change. So that will be studied by this differentiability, by this topic. Then it is said to be differentiable. Your function is said to be differentiable at a point. Differentiable at a point if it has a well defined tangent. Just remember this, well defined tangent. That means it is also called finite slope. Or okay, if it has your well defined tangent or finite slope, then your function is differentiable at that point. Next is what differentiability implies, that it is local linearity of the function. That means if at some point a your function is differentiable, then near this point, near x equal to a, your function is almost linear, is almost a straight line. Okay, that means that so local linearity means your function looks like a straight line. When you close to the point x equal to a, it will means at that point in the neighborhood of point x equal to a, or near the point x equal to a, your function is almost a straight line. This is how we can define the local linearity of the function. Next come to the mathematical definition. So this is important for your. So what is the mathematical definition? A function f of x is said to be differentiable at a point x equal to a, at a point x equal to a, if the following limit exists. If this limit exists, limit h tends to 0, f a plus h minus f of a divided by h. If this limit exists, then the function is called differentiable at point x equal to a. Otherwise, you can also define like this: limit x tends to a, f of x minus f of a divided by x minus a. If this limit exists, then also you can say that your function is differentiable. This is actually main definition. This is your main definition. If this limit exists, then the function is differentiable at point x equal to a. And from this limit, we can reduce this formula, because when you put x minus a is equal to h, okay, then your x will be what? A plus h. Now your limit as x tends to a in the previous limit, so when x tends to a, when x tends to a, your h will tend to 0, because your h equal to what? X minus a, is not it? So when h tends to 0, sorry, x tends to a, your h, that means your x minus a, will tend to 0. So this limit will reduce to, what? Limit h tends to 0, limit x tends to a, and that will be reduced to limit x tends to, sorry, h tends to 0. H tends to 0. Now your f of x will what? F of a plus h, because x equal to a plus h. So f of a plus h minus f of a divided by x minus a, and we put what? X minus a equal to h. So in place of x minus a, we can put h. So this limit will reduce to this. So you can apply this limit or this limit. Both are equal. Okay. We can use this limit, we can use this also limit. So if this limit exists, then, or it has finite value, then we say that function is differentiable at point x equal to a, at point x equal to a, and we denote it as f dash a. We denote this as f dash a, that is your derivative of a at point x equal to a, derivative of f at x equal to a, and the value of the limit will be equal to the value of the f dash a. Clear? Now come to the geometrical interpretation. Come to geometrical interpretation. How geometrically we can interpret it? Your f dash a, that means your derivative f dash a, this derivative f dash a, what represents it? It represents the slope of the tangent to the curve y equal to f of x. F dash f represent what? This is the slope of the tangent of the curve to the curve y equal to f of x at point x equal to a. If this is your y equal to f of x, and this is the point x equal to a, this is the point a. So if I write this tangent, okay, this is the tangent, then if this is the tangent, then this is the slope of the tangent. What represents? F dash a represent slope of this tangent. Okay, this f dash a represent slope of the tangent. Now using the slope of the tangent, then you can write the equation of tangent also. So you just remember that f dash a represent what? This is the slope. Slope of what? Slope of tangent. Slope of tangent to what? Slope of tangent to the curve y equal to f of x. This curve. This is the curve y equal to f of x, and this is the tangent, and f dash a is the slope of the tangent at point a. This is the geometrical interpretation of the derivative. Now next come to the one-sided derivative. That means we can find left hand derivative and right hand derivative. So what is your left hand derivative? Left hand derivative means limit x, you can write, this is our formula, actual formula, limit x tends to a, f of x minus f of a divided by h, is not it? Now since we are going to find left hand derivative, then we can write it as limit x tends to a minus. So what is a minus? A minus means this is less than a, so we can write this as f of a less than a means what? A minus means this is less than a, or we can write it as a minus h, because it is less than a, h tends to 0, h is a positive number, so h tends to 0, and we have to find a minus, means a less than a. So to represent a minus, we can write a minus h. So here your f of x means f of x tends to a minus, so it is f of a minus h minus f of a divided by h. Okay, divided by h. So your formula, this is your left hand derivative, or you can write this as this will be equal to limit h tends to 0 f of a minus h minus f of a divided by h, because divided by minus h. Why it is minus h? Because it was x minus a, f of x minus f of x minus f of a divided by x minus a. So if I put, okay, let me explain again. This is our formula. Limit h, your x tends to a, limit x tends to a, f of x minus f of a divided by x minus a. So put your x tends to a minus. X tends to a minus means your left hand derivative LHD. So limit x tends to a minus. Okay, so since it is a minus, it will be f of a minus h minus f of a divided by, in place of x we are going to put a minus h minus a. Okay, so your a cancel, so your LSD will be limit h tends to 0 f of a minus h minus f of a divided by minus h. This is your left hand derivative, is not it? So here this is the formula, limit h tends to 0. This is your left hand derivative, limit h tends to 0 f of, this is not f of a plus h, this is wrongly written. This is f of a minus h minus f of a divided by minus h. Just rectify it. This is your limit h tends to 0. H tends to 0 minus, here it is written. So you can modify it as f of limit h tends to 0 f of a minus h minus f of a divided by h. Okay, sorry, minus h. This is your LSD. This is your LSD. Similarly, for your right hand derivative, we can write, and the notation here, this is the notation. Here this is the notation for left hand derivative. F dash a minus, minus is for left hand derivative. Similarly, for right hand derivative, RHD, we denote this as f dash a plus, and what will be the formula? This will be limit x tends to a plus, because your right hand derivative a plus, f of x minus f of a divided by x minus a. This is our original formula, and only we take x tends to a plus. Now a plus means it is a plus h. A plus means just greater than a, and we put this as a plus h. So it will be h tends to 0. In place of x put a plus h. So f of a plus h minus f of a divided by a plus h minus a. So a and a will be cancelled. So what it will be this? What will be the final formula? Limit h tends to 0. F of a plus h minus f of a divided by h. So this will be the right hand derivative. Okay. So you just remember these two. One is LSD. One is LHD. This is your limit h tends to 0 f of a minus h minus f of a divided by h. This is your left hand derivative, and your right hand derivative will, this is minus h, and right hand derivative will be limit h tends to 0 f of a plus h minus f of a divided by h. You just remember these two formula, and using these two formula, your LSD and RSD, we will check the differentiability of the given function at any point. Okay. Now, what is the condition for differentiability? When the function will be differentiable? When your LSD is equal to RSD. When your LSD is equal to RSD, the function will be differentiable. So, for the differentiability of the function, the LSD must be equal to RSD. Okay, function is differentiable if and only if your left hand derivative will be equal to right hand derivative, and both the limit exist and are finite. Okay, your left hand derivative should be equal to right hand derivative, and both should be finite, because if both are infinite, if one of them is infinite, then it will be also not differentiable. Okay, it is also not differentiable. So we have to remember that this left hand derivative should be equal to right hand derivative, and both limit exist and they are finite. They should be finite. If the infinite result we will get, then it will be not differentiable. Limit must exist and they must be finite. Now come to the next slide. What is the relation between differentiability and continuity? What is the first point? Every differentiable function is continuous. If a function is differentiable, then it also continues. If every differentiable function is continuous means what? If I check a function is differentiable at a point, then it is also continuous at that point. But the converse is not true. If a function is continuous at some point, then we cannot say that it is differentiable or not. It may be differentiable, it may not be differentiable. Okay, so differentiability implies continuity, but continuity does not imply the differentiability. Okay, for example, if I consider fx equal to mod x, now fx equal to mod x, how it is defined? Your fx equal to mod x, and mod x is defined as what? Mod x is defined as x when x greater than or equal to 0, and minus x when x less than 0. Okay, mod x is, again I did right, mod x is x when x greater than 0, minus x when x less than 0. Okay, x greater than or equal to 0, it is x less than 0, it is minus x. Now if I differentiate it, it will be what? For derivative of x it is 1, derivative of minus x is minus 1. You can check x greater than or equal to 0 and x less than 0. You can also check like this in such method. Okay, so for x less than greater than or equal to 0, the result is 1. X less than 0, the result is minus 1. Okay, so they are not equal. Otherwise, you can say like this. You can check like this. Your left hand derivative. What is our formula? LSD means your limit h tends to 0 f of a plus h minus, f of, this is your RSD. This is your RSD. F of a plus h minus f of a divided by h. This is our RHD, right hand derivative. So since our function is since our function is this is our RHD. Function is what? F of x is mod x, and point is what? At 0 we have to check. At x equal to 0 we have to check whether it is differentiable at that point or not. So x equal to a, and a is what? Here a equal to 0. So at 0 we have to check. So RHD means limit h tends to 0 f of 0 plus h, because a equal to 0, minus f of 0 divided by h. So now limit h tends to 0, because f of x is mod x. So f of 0 plus h means f of h, and it will be only mod h minus f of 0, because 0 mod 0 means 0. So it is 0 divided by h. So mod h is always h. So h by h is equal to 1. The value is equal to 1. So RHD is equal to 1. Similarly, you can find LHD. What is LHD? LHD means LHD. So what is LHD? Limit h tends to 0 f of a minus h, a means what? 0. So here put 0, f of 0 minus h minus f of 0 divided by minus h. So that is equal to limit h tends to 0, f of minus h means minus h mod, and f of 0 means 0. So minus h mod divided by minus h. So minus h mod is always plus h. So plus h. So limit plus minus h by minus h. Mod of minus h divided by minus h. So it is equal to minus 1. So left hand derivative is minus 1. Right hand derivative is plus 1. So they are not equal. So function is not differentiable. So you can also show like this. So since left hand derivative is not equal to right hand derivative, so function is not differentiable. Function is not differentiable at that point. So come to the next slide. So these are some example. You can check function is differentiable. Fx equal to x square. Fx equal to x square. It is also this question also we have checked, and function is sin x. If it is sin x, then f dash x is equal to cos x. It is differentiable. You can also find your LHD and RHD at that point, and you can check at any point. At everywhere it is differentiable. Similarly, fx equal to x square is differentiable everywhere. Function is here x square. Okay, and one thing is that you can see here, when you find the graph of the function f of x equal to mod x, you will get a sharp point at x equal to 0. This is your 0. So at 0 we will get a sharp corner. This is a sharp corner at x equal to 0. So whenever we will get this sharp corner, then at that point function will not differentiable. Graphically you can also say like this: when we will get a sharp corner, then this point, at this point function is not differentiable. Okay, so these are some basic differentiation rules. Derivative of constant is always 0. Derivative of constant is always 0. Then derivative of x to the power n is n into x to the power n minus 1. These are the formula we have to remember. Then derivative of f plus g, that means separately we can derivative f dash plus g dash, then fg whole dash, that means product formula fg whole dash, it will be f dash into g plus g into f dash, sorry, g dash into f, not g dash into f dash into g plus g dash into f. Similarly, f by g whole dash, derivative of f by g, this is the division formula. It will be what? F dash into g minus f into g dash by g square. And this is the chain rule. If f is a function of gx, f is a function of gx, not only x, it is a function of gx. Then what we have to do? First we have to differentiate with respect to gx. First we have to differentiate your we have to differentiate f of x with respect to gx. Then again we have to differentiate your gx with respect to x. This is our chain rule, because f is a function of gx. F is a function of gx, not only x, it is a function of gx. So directly you cannot differentiate with respect to x. So first we have to differentiate with respect to gx, then again we have to differentiate gx with respect to x. So this is the chain rule. Now these are some formula. Derivative of constant is always 0. Derivative of x will be 1. Derivative of x to the power n is n into x to the power n minus 1. Derivative of a to the power x is a to the power x into ln a. Derivative of e to the power x is e to the power x. Derivative of ln x is 1 by x. And these are some formula you have to remember. You can just note down all this formula. Okay. These are some formula. Now what is the application of this differentiability? So first we will get the slope of the tangent by finding your derivative. We can find the slope of the tangent line and normal line. Once you get your slope of the tangent line, then you will also get the slope of the normal line. Then this is represent a rate of change, because this is the derivative of a function with respect to another function. This is the rate of change, because velocity is what? This velocity is ds by dt, derivative of displacement with respect to time. So this is the rate of change of s with respect to t, rate of change of s. So next is this differentiability gives the optimizations of the function, the maximization or minimization, maximum value and minimum value of the function. Then curve sketching and analysis, it will also help. It will also help in curve sketching and analysis of the function. Then this is the summary of the discussion that we have discussed in the previously, that differentiability requires the existence of the finite and unique derivative, and differentiability means continuity, but converse is not true. Then sharp corner, when we will get a graph and we will get a sharp corner or cusps, it implies the non-differentiability. When you will get a sharp corner, at that corner the function will be not differentiable. Then differentiation rules simplify the computation. Then there are some problems we have to practice. So this is the first example, because differentiability of x equal to mod of x minus 1 at x equal to 1. When you will check for the differentiability of the function at x equal to 1, then we can write the function like this, because it is fx equal to mod of x minus 1, so it will be x minus 1 or minus of x minus 1 according to the value of x. So when it will be x greater than equal to 1, it will be x minus 1, and when x less than 1, it will be minus of x minus 1. So this is the definition of the given function. Now you can check here the left hand derivative and right hand derivative like this. If you check the left hand derivative, this will be minus 1, and for the right hand derivative it will be plus 1. So both are not equal. So if they are not equal, then function is not differentiable at that point. Next example is f of x equal to sin x square, then find f dash x. So because it is your composite function sine, this is not only a function of x, it is function of x square. So what we have to do? It will be this derivative. First we have to differentiate with respect to x square. So dy dx of divide dx of x, divide dx square of sine x square, and again I have to differentiate this x square with respect to x. Okay, this is the formula. According to chain rule, we have to do like this: d by dx, that means df by du, because if you put u equal to x square, then df by du, then again we have to differentiate du with respect to x. So df by du will be cos u, sine derivative, and d by dx of x square means 2x. So just multiply it, it will be 2x into cos x square. So using chain rule, we can differentiate the function like this. Now this is another function, fx equal to x to the power 1 by 3. This is the differentiability. How to check? Just find the derivative, because we have the formula dy dx of x to the power n, and this is your n into x to the power n minus 1. So just use this formula here, n equal to 1 by 3, and it will be what? 1 by 3 x to the power minus 2 by 3, and you can write like this. And you can check here, if your denominator, you can see the denominator, if the denominator will be 0, if the denominator will be 0, the f dash x will be undefined, f dash x will be undefined at x equal to 0, because it will be infinity, the value will be infinity at x equal to 0. So it is differentiable at every point, but at 0 it is not defined, but at x equal to 0 it is not defined. So it is not differentiable, it is not differentiable at x equal to 0, but differentiable for all point x not equal to 0, but at x equal to 0 it is not differentiable. Okay, so this is a note we have to see. This is a point that should be noted, that at x equal to 0 it is undefined, that means it is not differentiable. That means why it is not differentiable? Because it is the value of the limit, means value of the f dash will be infinity, value will be infinity at x equal to 0. So whenever we will get such type of result, infinity or minus infinity at any point, then the curve has a vertical tangent. It is not differentiable, it is not differentiable, and graphically you can see, or graphically you can interpret like this: a vertical tangent will exist at that point, a vertical tangent will exist at that point. Whenever you will get infinity or minus infinity, you can say that a vertical tangent exists at that point. Okay, thank you. We will meet in the next lecture. Thank you.